Welcome. Today we're going to continue with word problems and we're going to work on age problems. How old somebody is or how long ago something was built, how old the building is, that type of thing. So our first problem is today Selma is 5 times as old as Frank, but in 10 years she will be only 3 times as old. How old are they now? So I like to make a table of this. And the first thing I'm going to do is write down who we're talking about. Selma and Frank. Now the next thing that I'm going to do is when I read this, I actually do not want to read the entire thing when I'm trying to figure out what to put in the table. The first column is today or now, and that is going to be today Selma is 5 times as old as Frank. Stop. If you start seeing in 10 years or 10 years ago, that's not part of the now. That's going to be in a little bit. So we're going to stop reading and we're going to write that setup. Selma is 5 times as old as Frank. Frank's not talked about. So Frank is the unknown. Selma is 5 times what Frank's age is. So if Frank is 2 years old, Selma is 10 years old, that type of thing. Next thing that I'm going to deal with is in 10 years. In 10 years. I stop reading there because if I continue reading, it's just going to confuse me. And the reason it's going to confuse me is because after that is how to set up the equation or inequality. And that's not what we need right now. We need in 10 years, or if it were years ago. In 10 years, well, if you're 15 now, how old will you be in 10 years? You'd be 25. You'd add 10 to that value. So we're going to add 10 to what they are now, 5x plus 10x plus 10. And that's how we're going to get the expressions for their ages in 10 years. Now we can say, what about in 10 years? She, meaning Selma, will be, is a form of is. She, being 5x plus 10, will be 3 times as old. Now the word only doesn't really affect our setup. 3 times as old as what Frank will be in 10 years. So 3 times x plus 10. So there is our setup of our equation. So we've named it, we've expressed it, and now we're setting up the equation. We're going to distribute to solve. We're going to continue to solve by subtracting 3x from both sides. 2x plus 10 equals 30. Subtract 10 from both sides. 2x equals 20. And finally, divide both sides by 2. X is 10. Now x, that's one of the things we have to know about. X represents how old Frank is now. So if I come back over here, I can say Frank right now is 10 years old. So that makes Selma 50 years old. And that's how you do it. All right. Let's try another example. Barbara is 6 years older than Matt, and Christy is twice as old as Barbara 3 years ago, the sum of all their ages was 41. Find their present ages. All right, so in this one, we are now no longer talking about just 2 people. Now we're talking about 3. The 3 people are Barbara, Matt, and Christy. We still need the now category. And it says Barbara is 6 years older than Matt. So Matt's not talked about. Barbara is 6 older, so x plus 6. Christy is twice as old as who? Barbara. So twice this. Now whether you write 2 parentheses x plus 6 or multiply it in 2x plus 12, it's up to you. 3 years ago. As soon as you see that, stop reading, write it in, 3 years ago. 3 years ago, you were younger. So it's subtracting 3. So I'm going to subtract 3 from all these. X plus 6 minus 3 would be plus 3. X minus 3. And 2x plus 9. 12 minus 3. What about 3 years ago? The sum of all their ages was 41. Now whether you write x plus 3 plus x minus 3 plus 2x plus 9 equals 41, or you add them up right as you see them, 1, 2, 3, 4x, positive 3, negative 3 cancel, plus 9 equals 41. Either one is fine. If you'd done it this way and then combined them, you'd get here, or if you did it straight. After that, we solve by subtracting 9 for both sides. Let's see, 41 minus 9 would be 32. And then divide both sides by 4. X is 8. Now, what do I want to know? Their present ages. Now sometimes it's actually helpful to leave yourself a little room on the left-hand side and just write in their present ages on the side. Let's see. This is years, instead of having to label each one years. So Matt is 8. Barbara is 6 more, remember we're using now, 8 plus 6 is 14, and Christy is twice Barbara, so 28. Or we could have said 8 times 2 is 16, plus 12 is 28. So there are your 3 present ages, and that's the end of that one. Here's our next one. City B is 3 times as old as City A. 6 years ago, the sum of their ages was less than 32 years. Find the possibilities for the present age of City B. Well, we've got A and B. We've got now, present age. City B is 3 times as old as City A. 6 years ago. So I'm going to subtract 6 from each of these. X minus 6, 3x minus 6. What about 6 years ago? The sum of their ages was less than 32 years. Was or is less than means a less than symbol. So the sum of their ages, x minus 6 plus 3x minus 6, less than 32. Now I solve my inequality. 4x minus 12 less than 32. I'm going to add 12 to both sides. 4x is less than 44. divide both sides by 4, x is less than 11. Okay. It doesn't actually want to know about city A, it wants to know about city B. But we need to take some things into account. All right. City A, city B. A is less than, because A is x, is less than 11 years old. So therefore, if x were actually 11, then B would be, in this case, less than 33 years old. Awesome. Okay. Well, 6 years ago, the sum of their ages. That means they both had to exist 6 years ago. So A has to be bigger than 0 for it to exist. Technically, it has to be bigger than 6 for it to exist now. Not 0, 6. So, therefore, city B has to be bigger than 6 times 3, 18. So city B has to be between 18 and 33 years old now. You can't go back in time before something was around and add its age to something else. So it had to exist 6 years ago, so now it has to be at least 6 years old. So that's why I use 6. Okay, let's take a look at another example. By the way, this is your final answer. Between 18 and 33 years, I should put years, old. Number 9, ratio of present ages of 3 paintings is 1 to 3 to 4. In 3 years, all right, let's stop reading. When you have things in ratio, let's call them young, middle, and old. Just to have a name for them, or A, B, and C, that'd be fine. Now, the ratios, when you have things like that, think of a recipe with ratios. If you have 1 cup of flour, 2 eggs, and half a cup of milk to make some kind of dough, right? If you double that, you have to multiply each of those items by 2. If you cut it in half, you gotta cut in half each of those by 2. So the 1 to 3 to 4 ratio, you can use 1x, 3x, and 4x, x representing the multiplier, to keep them in that ratio. The next thing it says is in 3 years. So that's future. So I'm going to add 3 to each of these. Again, do not read past the in 3 years until you filled in this part of the table. I forever see students try to fill this in with stuff from what is for the equation. It's not how it works. So you fill in this part, then use this to do what's after the in 3 years. The sum of their ages will be, is, less than 81 years. The sum of their ages, x plus 3 plus 3x plus 3 plus 4x plus 3. So that would be 8x plus 9 if I add these up. Less than 81 years. So now I'm going to solve this by subtracting 9. dividing both sides by 8. Now I know that x is less than 9. Now, let us take this youngest, middle, old. If x is less than 9, then the youngest is less than 9. The middle is less than 9 times 3, 27, and the oldest is less than 9 times 4, 36. They have to exist. Currently, maybe the youngest was just painted, but we can't use 0. I guess we have to use 0. So they all have to be greater than 0. We don't have a choice there, because we can't say 1 day or 1 minute or 1 hour. So we just have to say greater than 0. We don't have much other option, because if you multiply anything times 0, you get 0. So unless you had a way of saying they were around for at least this much, you wouldn't be able to do any more with that. So they all exist, and the youngest is less than 9 years, middle is less than 27 years, and the oldest is less than 36 years. And that's it for today. Have a great day.